welcome back to Math Simplified by HM channel for another deep dive into similar triangles. Please take a moment to subscribe and enable notifications. Having already covered the similarity tests and area ratios property, we are now ready to explore areas of similar triangles. Please have your notebook ready, pause as necessary, and let us jump in to prove the theorem of areas of similar triangles, a visual geometric proof. We read the theorem statement carefully. When two triangles are similar, the ratio of areas of those triangles is equal to the ratio of the squares of their corresponding sides. So, what they have given in this theorem statement, when two triangles, means there are two triangles which are similar, then the ratio of their areas is equal to the ratio of the squares of their corresponding sides. Now we will break theorem statement in two parts, given and to prove. Given that there are two triangles similar to each other, so we take triangle ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR. As these two triangles are similar to each other, by definition of similarity of triangles, we get AB upon PQ is equal to BC upon QR is equal to AC upon PR. And what we have to prove? Area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. To prove this, we need a simple but critical construction. Draw altitude AD perpendicular to BC and altitude PS perpendicular to QR. Now we will concentrate on these two figures. The area foundation, we know the area of triangle is 1/2 into base into height. Therefore, the ratio of their area is area of triangle ABC upon area of triangle PQR is equal to BC into AD upon QR into PS. We can write this as area of triangle ABC upon area of triangle PQR is equal to BC upon QR into AD upon PS. Name this as equation 1. Now the hidden triangles. In triangle ABD and in triangle PQS, we have angle B is equal to angle Q given since triangle ABC is similar to triangle PQR. Angle ADB is equal to angle PSQ is equal to 90 degree by our construction. Therefore, according to the AA test, triangle ABD is similar to triangle PQS. Now, the step is to aligning the proportion. As triangle ABD is similar to triangle PQS, its corresponding sides are proportional. AD upon PS is equal to AB upon PQ. Name this as equation 2. But from our original given triangle ABC is similar to triangle PQR, we know all sides share the same ratio. Therefore, AB upon PQ is equal to BC upon QR. Name this as equation 3. Now, combining 1, 2 and 3, since AD upon PS is equal to BC upon QR, we replace AD upon PS with BC upon QR. We substitute this into our original area equation, that is area of triangle ABC upon area of triangle PQR is equal to BC upon QR into AD upon PS, which we have named as the equation 1. We replace AD upon PS with BC upon QR. We get area of triangle ABC upon area of triangle PQR is equal to BC upon QR into BC upon QR is equal to BC square upon QR square. The final conclusion, given that AB upon PQ is equal to BC upon QR is equal to AC upon PR, which implies that squaring each term we get AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. And we have found that area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square. Therefore, area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square is equal to AB square upon PQ square is equal to AC square upon PR square. Proved the theorem here clearly. Now just the another magic. Combining 1, 2 and 3, since AD upon PS is equal to BC upon QR, we substitute this into our original area equation, that is area of triangle ABC upon area of triangle PQR is equal to BC upon QR into AD upon PS. This is the equation 1. Now we replace BC upon QR with AD upon PS. We get area of triangle ABC upon area of triangle PQR is equal to AD upon PS into AD upon PS gives AD square upon PS square. So we have area of triangle ABC upon area of triangle PQR is equal to AD upon PS bracket square. This means that area of triangle ABC upon area of triangle PQR is equal to altitude 1 upon altitude 2 bracket square. Thus, triangle area ratio is equal to in bracket altitude 1 upon altitude 2 bracket square. So, this is the magic. Explore, can this be true? For triangle area ratio is equal to in bracket median 1 upon median 2 bracket square and triangle area ratio is equal to in bracket bisector 1 upon bisector 2 bracket square. Comment me. Thanks for watching and keep up with that geometry practice for exploring the geometry of the world around you. Before you go, please share this with your colleagues, drop a like and hit that bell icon. If you don't have already, make sure to subscribe so you don't miss our upcoming videos. Have a great time.